Hello, welcome to Technoveda Solutions.
In this video, we will discuss about the object-oriented programming concepts, generally known as OOPS concepts. Let's begin. Object-oriented programming is based on implementation of solutions similar to the real-world entities. That means the way we do the programming in OOPS concept is very much similar the way we solve the problem in our real world. The same process is followed. That's why it is called very much similar to the real world entities. One more important thing is in this concept, the data and functions which are operating on that data are bound together. If we see the comparison between the structural and object oriented programming models, in structural model, once we get the problem definition and we find a solution for that, then for implementation purpose, we divide that solution into a small modules called functions. Whereas in object oriented programming, once we get a problem definition, we look into what are the objects required to find a solution and then we develop the program accordingly. So here we divide it into smaller objects. So structural model is said to be a top-down approach wherein we first find the solution and then we divide it to a smaller sections or a modules which are called functions. Then we integrate them. Whereas in OOPS, it is called bottom-up approach because first we find the objects required for the solution, then we start developing a process for the solving the procedure or the solution. In structural model, the data is not very secure because functions play an important role or functions are predominant in nature. Whereas in OOPS, we have a data as a predominant and data gives more importance to the data and we make them very secured. Hence, structural model is referred as solution inspired and OOPS concept is referred as real world inspired. We can see some of the examples here for the both the type of paradigms. For structural model, we have C, Basic, Fortran, Pascal, etc. Whereas for OOPS concept, we can see C++, Java, Python, all comes under OOPS. Now let's see the features of object-oriented programming. The first one is class and object. We will discuss each one of these features in detail. Let's just we'll go through the list now. The class and object will provide us a characteristics of reusability and modularity. Then we have another feature called encapsulation. It provides us data hiding. Then we have abstraction that also provides data hiding and also reusability. Then we have inheritance. This also provides reusability. Then finally we have polymorphism. These are five important features of object oriented programming. Now let's dive deep into each one of them. First one, that is classes and objects. Basically, class is a group of logically related data and functions. Just now we said that the functions and data will be bound together. That binding is done as a class inside the class. The data what we need and the function associated with that data are put into a one class. Just by creating a class, that itself does not consume any memory. The memory is consumed only when objects of the class are created. That means we can say that a class is like a derived data type. Just dividing a just declaring a type of data type will not consume any memory. When we declare a variable of that, that is when the memory is consumed. So when we create objects of a class, that is when the memory is consumed. Objects are also referred as instances of the class. Here we can see the example. The class is a keyword and then we give a class name. Then we can have a data type and a variable. So we can define required variables here. Then we define the functions for operating on that variables. Then these all data and functions are enclosed within a pair of braces. Then we declare a variables of this class, that is objects. If you see this implementation, it is very much similar to the structure implementation of C program. Now, the next feature is encapsulation. It is a mechanism of binding data and functions that use them. So, whatever the data we want and the function we want, we bind them together within the class. That concept is referred as encapsulation, where encapsulating data and function within a particular framework. That is encapsulation, which keeps both data and function safe from external access. The external access is restricted. A programmer or a developer can decide how the external functions will be able to access the functions which are defined inside the class. We'll see that in the upcoming discussion. So, encapsulation provides us data hiding. Then we have abstraction. Data abstraction is a programming technique that relies on the separation of interface and implementation. That means, in general, we are trying to use certain objects without knowing the implementation of that. That is what the abstraction means. Abstraction is using a certain things without knowing its implementation. For example, if I want to give the analogy to that, suppose if you are a board level designer, you want to take a different ICs for required for the application development. As long as that ICs are giving a required output, we are not worried about their implementation. So our abstraction level stops at chip level. If I'm a chip designer, my abstraction level will go to gate level design. I want to use different gates to implement that operation which is required inside the chip. So my abstraction will stop at gate level. I don't want to get into the gate, how that gate is implemented or developed or realized. As long as that gate is giving me a required output, I'm happy with that. I'm just using that. That means we are using something without knowing its implementation. If I'm a gate level designer, then I have to go up the transistor level of abstraction. Like that, depending on what level we are working, our abstraction layer changes. Similar to here, that in programming, we have a abstraction model in OOPS. That is, we will be using certain objects without worrying about their implementation. So that provides us reusability and also data security. Next, we have inheritance. It is a feature which enables us to create a new classes from existing classes. The new classes are called derived. The existing classes are called base class. That means we will be able to create a derived class from the base class. That means the derived class will acquire all the property of the base class. When I say property, that means the functions what we define in the base class, they can be used in the derived class. Along with that, we can also define additional properties in the derived class. Say, for example, I want to have a car. So I will define a base class of the car. The basic requirement of the car is given in the base class. Engine is required, chassis is required, body is required. So all that functionalities will put in the base class. Then I will create one derived class from that, wherein I will add certain features. Anyway, I need these basic functions. Along with that, I will add some power windows, central locking system, some additional features I can add. That becomes a derived class, wherein I will be adding some additional features to that. So we can develop the new class using existing classes. So how do we derive it? The classes, derived class name, and then you have access specifier and base class. Anyway, these things we will see again in detail. Then we have another feature called polymorphism. occurs when there is a hierarchy of inherited classes. So there are different polymorphism. So polymorphism is basically a multiple implementation of the same function. More than a function is defined with the same name. We know that generally we cannot define more than one function having the same name. But polymorphism gives us that flexibility. So function will call the respective the functions will be called depending on the object which is calling those functions. So this also allows us something called as late binding or a dynamic linkage. We will discuss that. So this is how the polymorphism is implemented. Broadly, there are two types of polymorphism, what we can see. One is compile time, another one is runtime. In compile time, we have two types. One is function overloading, another one is operator overloading. Both come under compile time polymorphism. Again, another category we have is runtime polymorphism. We have two types of implementation there. One is function overriding, another is virtual functions. Okay, so we got a brief idea of different features of the object oriented programming. So that's it for this video. If you like the video, please click a like button, subscribe the channel and share the video with your friends. If you have any questions, please add the comment. Also, you can mail to technoveda79 at gmail.com. Thank you.